Hello everyone.
Welcome back to the channel and to another video about programming. I have been kind of lurking in different subreddits and I have seen this question a lot, that how do you take a problem and start coding? So today we are going to do something fun to demonstrate that. Someone called Coding Horror had this specific project where a lot of people were interested. It's called Basic Computer Games. So these guys had a link to the actual old game. So here is a site. What we are going to do is, in a series of video, we are going to try to write these games ourselves. There are total 96 of them. So in today's video, we'll take a look at the first game. I have been fascinated with Go language for last couple of years. So let me write it in Go and explain to you at the same time, how do we go from a problem to code, solving that problem. Here we go. So first we need to understand what the game is. The game is called Acey Ducey. This is a simulation of the Acey Ducey game. In the game, the dealer, the computer, deals two cards face up. You have an option to bet or not to bet depending on whether or not you feel the next card dealt will have a value between the first two. The initial money, Q, is set at $100. You may alter the statement 110, which is here. The game keeps going on until you lose all your money or interrupt the program. So if you read through the basic program, the loops, the functions, all those are created using goto function. So that makes it very difficult to read. But if you read it, there is a pattern that emerges. Along with the description of the game and reading the code, you can understand a few things. So there is a player. So let me draw a player. That's our player. Okay. And then there is a dealer, which is a computer. So let's draw a computer. Okay, that's our computer. Does it look like computer? Yeah, probably it does. You know, one touch is needed. During the days of BASIC, there used to be a large floppy drive. If not on the computer, it would have been in an additional peripheral. So let's play the game. To start with, you, the user, have $100. So the computer shows you the details of the game. So details of the game is this: Acey Ducey is played Acey Ducey card game and blah blah blah. And then the game starts. It shows you that you have $100. Once it tells you how much money do you have, it will draw two cards. So let's say the first draw, the cards are 2 and 9. At that point of time, it asks you to bet. So there is some kind of asking. You take the next decision, that do you want to bet or not. If you do not want to bet, you will say my bet is 0. Otherwise, you will say my bet is, let's say, how much money do I bet? I bet, let's say, $25. So the computer, next thing it will do is it will draw a third number. So these numbers are not, they are drawn randomly, but they are drawn from the playing card group. So that means starts with 2 and ends with 14, and number 11 is replaced with Jack, number 12 is replaced with Queen, number 13 is replaced with King, and number 14 is replaced with Ace. Let's say the computer says, you know, I have drawn 14, which is also the ace. This 14 number is not between 2 and 9. So the computer takes the decision that you lose. So it tells you lose. And the next round of the game starts. So let's take another example of the round. So next round, this comes out as 3 and 6. It asks you to bet again. So it asks you bet. You, this time, you are thinking, you know what, between 3 and 6, there is only 4 and 5. What are the chances of computer again drawing 4 or 5? Very less, right? 30 numbers to draw from. And it's so you will say, you know, I will not bet. If you do not bet, if you say $0, computer will mock you and say, or you may say, you know what, even though there is very little chance, I don't care, yellow, I will bet $30. Behold, the computer's next time picks up 5. So if it does, it will actually tell you that you win. So at this time, when you lost your money, you lost $25. So your money, you had 75 left. When you bet 30, if you win, you get that 30 back. So at this point, you had $105. That's how the game keeps on going. There are few cases you'll have to understand. You can never bet more than the money you have. If you said I want to bet $150 or $250, computer will say no buddy, you do not have that much money. You bet too much. And you only have $100. That's one scenario. Because this is a game played by typing, what if instead of 250 you say something like YOLO? That's not a valid number, right? So the computer should tell you, are you mad? Or something like that. Second thing is, this whole thing needs to have a loop, because the game will actually be played in a loop. Before the loop starts, should at least for once show you info about the game. And when the loop ends, the computer should ask you, do you want to play again? It will tell you to either type yes or no. And if you type yes, the game goes back to the start of the loop, where you again start with $100 and you two start playing. But the game info is not shown again. So once we understand the details of the game, so after we understand the game, after we understand the logic of the game, this process is to try to reiterate in your mind all the different parts of the game and things that you need to keep a lookout for. In this step, we will essentially break down the game into smaller chunks. We will write them down so that we do not forget about them. So the first chunk is main loop of game. In the main loop of game, starts with player having $100, ends when player does not have money, asks player if wants to continue, continues loop if player says yes. Okay, that's the main thing. So from this, you can consider this as pseudocode, or you probably can write this in the pseudocode, but we are just breaking it down. We are not yet in the pseudocode level. So this is the main loop of the game. Second thing, we'll have to draw cards. We'll have to draw cards 3 times. Right? First 2 cards together and then a third card. So each time we draw, the details are that cards will be between 2 and 14 included. So what it means is that it will include 2 and 14 in the choices. That's our choices of all the cards. So when we are choosing for the first time, when we are choosing 2 cards, there are certain details we need to worry about. Our first detail will be choose number between 2 and 14, and again included. So this included part is important when you write your loop. That will do for the first card that you choose. But when you choose the second card, this will become your card 1. But when you choose the second card, that this thing itself is not enough, because if you choose this, and what if this card is same as the first card that you chose? Along with this, you will have to do certain other things. The other things will be card is not equal to card 2. That's also one a logic you'll have to implement. Second thing is you want to provide the player with a range. So you may want to provide the first card as the lower number and the second card as the higher number. If you want, you can also say card is more than card 1. These are the additional logic that you'll have to keep in mind when choosing card 2. Now in case of card 3, so this is which you are choosing after the player has bet, you just choose any number between 2 and 14 included. So that's the details about the card. Now we have some kind of logic in mind. So that's why this step is very important. You are looking at smaller part of the problem and you are mulling it over in your mind, mostly discovering new things about the problem that you would not have thought when you just read the description of the game. What else comes to mind? The third thing that comes to my mind immediately is validation. We talked about it when we looked at the detail of the game. Validate that player enters a valid number. So basically it's only digits. So what we can do probably whatever player types in, it will be string. We'll have to convert it to integer. And if there are errors in that conversion, we can simply tell player this is not a valid value that you have tried to bet. Second thing is player cannot bet more than what they have. So that's another validation we'll have to do. Now what else? We have drawn the cards, we have the main loop, we have validation. Fourth thing is calculate winnings or losses. So every time player wins, add the bet to the total. That one calculation we'll have to do. Every time player loses, subtract bet from total. Okay, this number, you can think in your mind that this number will never be negative, because we have validated before that player is never betting more than what they have. So when we subtract the bet from the what they have, it will always be a positive number. I think that's the most of the detail of the logic. So this is the part where you are breaking down bigger problem into smaller chunks and you are mulling it over in your mind, writing down the details of those smaller chunks so that later on you can refer to these. From this you can move on to the next step, which is writing the pseudocode. Let's talk about pseudocode. So the pseudocode is not like your actual code. It does not have a syntax. Every programmer would have developed their own way of writing a pseudocode syntax. But if you follow a style from a programming language, then it helps you write program from a pseudocode in that programming language. So as we said, we'll have a start and we'll have an end. Now in main, we will show the user some info about the game. So we'll say show info to user. We have shown the user, we will need to do some initialization. So we'll say initialization, and we'll basically say what you are initializing. You are initializing total amount 100, and you are also initializing a current amount. This is something that we'll have to keep a tab on. And after this you will start the main game loop. So you'll say main game loop. This is a loop. So in the main game loop, the first thing you are doing is show player how much money they have. But the moment you write this, you are like, aren't we going to show player how much money we have, again and again after every bet? So does it sound right to just do it outside here? Then where will that loop come? So we'll come to that. But the moment you have defined the main game loop, but this loop you'll have to define a starting point and an ending point. So we will define a exit criteria for the loop. If player money is 0, then exit. And when writing code also, you define the exit criteria first in a loop so that you don't end up writing an infinite loop, and it's quite important. Once you have shown player, then ask player to bet. When ask player to bet, you are waiting for player information or player input. Let's say we mark this with player input. This process player input will be also validate the player input, and you come up with the bet. Not initialize, let's say define bet. That's a value that is undefined outside of before asking the player. But as soon as we come out of this ask player to bet, we want a value here. So this is basically assigning, this step is assigning the bet value. Mock player if bet is 0. At this point the bet is placed, but before the bet we forgot a step here. So we'll say draw cards, draw 2 cards and show to player. This is a major step, because in this you are doing several sub steps. As part of draw second card, you are doing card 2 is greater than card 1. I think that will take care of both. You are drawing a card between 2 and 14. So you can probably write a easy win. You can write a function for that. So once the cards are drawn, the next thing you will do here is show the user the cards. So now draw a third card for user between 2 and 14 included. This is the same step. You can use the same exact function that you defined for drawing this first set of cards, only there is no restriction. So you can say judge winning or loss. Card 3 is greater than card 1 and card 3 is less than card 2. And based on these winning or losses, you will basically set won or loss. If won, you want to do couple of things. You want to congratulate user by saying you win. You want to calculate total value, and that will remind you that once they bet, we forgot to reduce that number. So outside of this ask player to bet, here you'll have to calculate current amount. Current amount equals to current amount minus bet. He won, so in this case current amount equals to current amount plus bet. If he lost, then if lost, or you can say else if lost, you can do the same thing. Instead of congratulations, say sorry. So it will be current amount minus bet. So you can define here else continue. So what that will do is that will show player how much money they have and will continue the same thing. Now outside of the main game loop, you can ask them, or you will have to ask player, do they want to play again? So this is another place where player will give an input. Alright, let's save this. So you can do more and more with understanding pseudocode, trying out the small functions and trying out how to draw, because that is the the next step. I don't know what step number it is. The next step is figure out the details of the code before you start writing. When you start writing it, write from top down, write the higher level first, and then slowly go into deeper level and write the details. But some of the details may be needed and very important for the functioning of your code. Like in our case, if you open the pseudocode, you can see we said draw 2 cards and said draw first card. So this in most of the programming languages will probably be a function. But that function will have implementation details where you will have to calculate random numbers between 2 and 14, including 2 and 14 in that. So different programming languages will have a difference in that regard, like how you implement it. So let's look at our program. I'm not going to write it manually, I have already written it, but we'll look at its detail and then play with it a little bit. So draw card, we basically put a seed and we create a random number between 2 and 14 by using this rand int n. We put the seed so that the int n does not follow a certain mathematical pattern and give us the exact same set of numbers. But when I'm drawing 2 cards, so I have draw cards, this is returning 2 cards, 2 integers. You can see the first card I can simply do draw card. But for the second card I am doing it in a loop and I am validating that card 1 is not card 2. Also outside of the loop I am validating that card 1 is lesser than card 2. If that is not the case, I am looping the whole thing. So it's going to go at it again and again and try to draw 2 cards where these criteria are all fulfilled. And I have these separate functions for showing game info, asking player again, show player amount. These I have created simple functions, but you don't need to, because it's one line. You can just put it inside the code. So let's look at the main loop and the main game. So this is my main function, which is the main game. As we wrote in the pseudocode, define the keep playing, which is the result of asking user if they want to play. We do show game info. We do it outside of the main game loop because we want to show it only once. In the show game info, we initialize a structure. This is basically just keeping the data, the total amount. And I do gameplay. See, by calling this gameplay, this becomes my inner loop. So if we go back to our pseudocode, the inner loop of playing one hand, that inner loop becomes this. Once the play is done, all the bets are placed and everything, then basically once the player has lost all the money, I ask them again, do you want to keep playing? So at this top level, you see the logic is very simple. Show game info, do in a loop, define a game, play it, ask player do they want to play again. If they want to play, if they don't want to play, break, otherwise do it in a loop. So that's your top level logic. Once you have written it, it's done. Second level of logic, now the play. Again, you can see that play has a for loop. In that we are showing player amount, we are drawing cards, we are showing cards, we are asking for a bet and capturing the bet amount, we are drawing the player card, we are showing the player card, we are determining if the player won or lost, and then we are calculating the winnings or loss. So let's run it and play it. Okay, so it shows me the game info and it shows me that you have $100. Here are your next 2 cards, 6 and 10. Let me try to bet $150. I have 100. So this is again, whatever program you write, when you are running it, you'll have to check it for the negative scenarios. It says, sorry, my friend, but you bet too much. You have only $100 to bet. What if I put minus 150? It says that is an invalid bet. What if I put a text like my name? That is an invalid bet. We have put all those validations as we talked about. So let me bet $25. And it picks up your card 6 and it says you lost because what was 6 and 10 and my card 6 was not within them. Sorry, you lose. You now have $75. So let me bet all 75 again. Your card is. Sorry, you lose. Try again, yes or no. If I say yes, it goes back to give me $100. 7 and king. I say, okay, let me put $25. Okay, I won and I'm now having 125. 7 and 10, let me put another 25. I lost, so I now have 100. Let me bet full $100. Say, try again? No. That's a fun little game. It's complete program in Go. The corresponding logic, breaking it down, writing the pseudocode, and then finally the code. Now the code I did not run through how I wrote. We have 95 more games to do that. So for those 95 games, I am not going to describe the pseudocode and the logic. I'm directly going to go to the code and probably write it in the video. So hopefully you liked this long form, more than 30-minute description of a way of how we took a game, a basic problem, and then wrote code about it. If you liked it, please give it a thumbs up. Subscribe to the channel for more awesome programming videos like this. And I'll see you with the next one. KISH out.